Good morning, everyone. Welcome to our SOLIDWORKS Suite Recommended Hardware Requirements webinar. My name is Joseph Martinelli. Feel free to call me Joe or Joey. Um, I'm, I serve as a technical support representative here at Hawkridge Systems. I am a PDM specialist, and I also do general installs, error support, and of course, hardware questions. I do have a background in IT, which definitely aids in this capacity. So, just a quick overview here. This presentation is supposed to be for more of the end user, customer, client, the SOLIDWORKS user. I've tailored this presentation to that audience. If you're server manager, IT specialist, PDM admin, there are definitely things in this presentation that will interest you. If you have more specific questions in relation to your application, definitely shoot me an email afterwards, give us a call. We'd be happy to help you with more specific questions. So, on our agenda today, we're going to be talking about all of the primary hardware components that affect you, the user. We're going to be discussing your CPUs, your processors, RAM, hard drives, video cards. I will be giving you workstation recommendations, model recommendations. We'll go over a lot of that kind of stuff. We're also going to be touching on some software related topics that are interlinked with hardware, like VMs. I have a general tips and tricks troubleshooting section later on, and then we'll have plenty of time for some questions later. So we'll start off CPUs, processors. This is sort of the first thing people look at and most often when they're looking at a computer and what to buy. If you look down at the bottom, we have some recommendations listed there. There's a lot of information in these, especially that Xeon. There's the type. It's an Intel Xeon processor. This is an E3 1270 V6, and then there's a number of cores and the speed here. And for you, you just want to know, well, what does this matter for me in SolidWorks? What does SolidWorks care about? So generally, what matters is clock speed. And that's what we're talking about. Hopefully my mouse is showing up here correctly. Like this 3.8 gigahertz here, this 4.2, 4.5 turbo. SolidWorks does not utilize multiple cores and threads. It runs on one core. So the clock speed that you get is per core. If you have a low clock speed, SolidWorks performance is going to suffer in comparison to a high clock speed. Now that being said, the next major consideration is, okay, so I know I want to get a fast processor, and I know I don't need one of those 20 core server processors. That's not going to help me because I can't use multiple cores. But do I want an AMD processor, or do I want an Intel processor? There are some applications in the SOLIDWORKS Suite where you definitely want to avoid AMD in general. I think this is more for visualized users, just a heads up. But in-house here at Hawkridge Systems, most of our machines, if not all of them, are running Intel processors. So we're generally going to recommend stick with Intel. That's what we have here. If you call in for support, we'll be able to better diagnose, and most of our recommendations are tailored with this in mind. So you say, okay, now I want a fast Intel processor, high clock speed. Well, do I want one of these i7s or do I want one of these Xeons? We do give recommendations for both. Well, this is where that next point comes into play. We want to know the application for your processor, for your workstation. To be honest, for the most part, general users, if you're doing, part and assembly modeling, making drawings, and you're dealing with assemblies that aren't getting, into the 10,000 part range, well, even the 5,000 part range and component range is fine. But that recommendation there for the i7 7700K, that was actually last gen's big name processor. Intel has now moved on to the 8th gen. It seems like every time I go on the internet, they're releasing a new line of processors here, but the equivalent for the 8th gen would obviously be the i7 8700K. You'll notice that Intel has a familiar naming convention as you look through the different generations of processors. And generally, that K processor, which is the unlocked version, meaning you could potentially overclock it if you really wanted to. That's a really good go-to processor. You'll notice even with the 8th gen here, very high clock speeds. The base clock is a little bit lower, but the turbo is a little bit higher. So that's a change they made there. For the 8th gen, these are 6-core processors. I believe for the 7th gen, they were 6-core processors as well. I might want to double check on that, but low power consumption, like I said, unlocked. Very reasonable price point. You can always look at the 8700 if that is becoming an issue, but these vary by about $50. And for the 7th gen, the 7700K in that generation, similar kind of thing. So you say, well, why are we talking about Xeons at all then? Well, while SolidWorks and a number of the applications in the SolidWorks suite don't care about which architecture you're using, be it the i7s or the Xeons, there are some applications, and we're specifically referencing simulation, PhotoView 360, and Visualize, where having additional cores and threads is actually beneficial because those particular applications can utilize them. So in the case that you're building yourself a Visualize render machine, maybe even pairing it with those, Visualize boost licenses so you can have offloaded renders. If you were looking at those kind of machines, you might want to consider aiming for one of these Xeon processors. Again, you wouldn't have to get into the crazy expensive lines, the E7s and etc. Looking at the E3 and E5 lines are generally going to do you well. One big consideration with Xeons, and if you'd even want to get them, is the price point. Xeon processors, their price goes up real quick. It's not quite an exponential curve, but it's getting close to it. As soon as you start delving into the 10, 12 core processors for Xeon, your price point jumps well above the $1,000 mark. So budget is a huge consideration when looking at those processors. And again, we don't need to go to that length unless we have an application that deserves that kind of processing power. So moving on, the next big component that everyone looks at is your RAM, or memory. Now I specifically put memory here up in the title to note you do not want to get RAM confused with hard drive space, storage space. Memory is a common term used to describe RAM, but it does not indicate your storage space on your machine. Just wanted to get that out of the way there. So, big question, obviously, how much RAM do we need? I think the official SolidWorks minimum recommendation might still be 4 or 8 gigabytes, but Hawkridge is going to recommend to you 16 gigabytes. Whether you're running a workstation laptop or desktop, we would say minimum 16 gigabytes. The reason we're no longer saying 8 is primarily due to Windows 10. If you boot up a computer with Windows 10 on it right now, just sitting at the desktop, you are on average using between 3 and 3.5 gigs of your physical RAM. That leaves SolidWorks with what, 4.5 to deal with. It's not much if you only have those 8 gigs. So we bump you up to 16 gigs. That's a very nominal price increase for most workstations, and you'll be sitting pretty. As always, as with the CPUs and with the other components we're going to be looking at, we do want to consider the application for this workstation. If you are, again, running something where you're going to be using larger models, building larger assemblies, possibly if you're doing a render machine, a visualize machine, a simulation machine, you will likely need additional RAM. For this, we'd probably want to look at 32, possibly even 64 gigabytes of RAM. Now, we did touch on visualize, simulation, and how those might require additional RAM. One other point I did want to make here, this is kind of an aside, a little bit more for the IT crowd, but still a consideration as a customer end user. RAM does have speed associated with it. For you techies out there, that's due to your motherboard front side bus. The RAM integrates with that, and it operates on a speed that should match or slightly exceed your front side bus. So if you're trying to tailor your machine for performance, you're looking for the best of the best, like you want your 32 or 64 gigs of RAM, but you want it to be at the fastest point it can be. Generally, when you're looking at big name vendor sites like your Dells, HPs, Lenovo's, etc., if they're listing a brand name for the RAM, those are usually going to be faster. The big brand names, they tend to have lower latencies, and just the RAM is going to be perform a little bit better. This usually won't make a significant difference for you, but again, if you're trying to build a tuned custom machine and trying to get the most performance out of it, that's where you'd go. Again, price point's going to be a little bit higher. Recommendation for RAM, obviously, we talked about 16, 32, possibly even 64 gigabytes of RAM, although that's better be tailored for your application. Again, your average user, 16 gigs, you're running Windows 10, Windows 7, dealing with parts, assemblies, models that aren't getting too crazy big, 16 gigs should serve your purposes. And moving on here, as soon as my mouse cooperates. Next big section, hard drives. I did want to take a quick moment, look at some of these pictures. I thought these were pretty interesting. And again, we're talking with a hardware enthusiast. But on the left there, at the bottom, under where it says HDD 3.5 inch, that's one of the old spinning drives, as we refer to them now. If you are still using a spinning drive, which, if you're looking at your computer specs and it says 5400 RPMs or 7200 RPMs next to your hard drive size, you're using a spinning drive. Generally at this point, due to the price point of the SSDs there on the lower right, price point's a lot lower, we want to start shifting our workstations toward using solid state drives. They are noticeably faster, even out the gate. Standard boot time for a spinning drive, looking at 20 seconds on the high end, and generally 30 seconds to a minute. If you switch to an SSD, you'll probably have a 10 to 15 second boot time. That's talking to your desktop. These are noticeable performance increases. Even newer, now we have M2 SATA and NVMe drives. You'll notice that oftentimes the NVMe drives are just a PCI Express adapter for an M2 SATA drive. You can kind of see that upper left drive there, and on the right, although they are different brands, basically it's that M2 drive on the left there plugged into that card on the right to process having that drive run over your PCI Express bandwidth. It's running on that bandwidth increases the speed. I think it's something like 2/3 or maybe even double, because you're utilizing your front side bus, and it's just, these are fast drives, both the M2s and the NVMe. Generally, if you're looking for drives like that, you're probably going to want an additional drive, but we'll get into that in just a second. The reason we're talking about these is because this is the future of hard drives. This is how you want to run SolidWorks, what you want to be working on. This is the platform. When it comes to size, yes, you have to judge what kind of application you're doing. Are you just doing small models, parts, small assemblies, maybe a few drawings? You can probably get away with a 500 gigabyte SSD or M2 SATA drive, no problem. If you need additional space, they have these drives going up to 1-2 terabytes now for the SSDs. I mean, a 1 terabyte solid state drive, when I was looking just now for a good one of those Samsungs, kind of same brand as the upper left there, I think it was 400 to 500, and then for a 2 terabyte, you're in the 700 to 800 range. These are big price points for a hard drive. However, they're not crazy considering overall computer budgets. So gravitate toward this when you're looking for space. Now, I did mention RAID here really quickly. For those of you who don't know, RAID is a hardware software feature that allows you to basically daisy chain hard drives together in order to increase read and write performance. Now, with those spinning drives down there in the lower left, this RAID would cause a significant performance increase. It was noticeable. It was worthwhile. With our SSDs, especially with the M2 and NVMe drives, we don't need RAID. The performance increase is negligible if it's even there, and to be honest, I recently dealt with a customer who had two of the SSDs in the lower right in RAID 0 configuration, and they were actually, according to them anyway, seeing slower performance than they had in their previous machine, which I think just had a single solid state drive. So, just making a quick point here, RAID may not always be a good move. In fact, it could potentially be a bad move. So stick with your SSDs, your M2s, NVMEs, and we don't really need to get into RAID or anything fancy with them. Those drives are sufficient on their own. I did want to touch a little bit on PDM server considerations in relation to hard drives. I'd still say if you're using spinning drives in your PDM server, unless you're dealing with, 4, 6, 8 terabytes worth of data in your vault, it might be a good move to switch over to some SSDs. Like I said, 2 terabyte SSD, $800. That's not a stretch for a PDM server, especially considering the read-write performance increases you'll gain. So your PDM archives are going to be stored on that, and all your users are going to be accessing them. That performance increase will probably be visible to the user. We touched on this earlier real briefly, multiple hard disks. Even if you're running a mobile workstation, so a laptop as your workstation, most now allow you to input at least 2 hard drives of the 2.5-inch variety. Now there are spinning hard drives. The HDD there says 3.5-inch. It's a desktop version. There are laptop versions of that, obviously. So whether you're working with a desktop or laptop workstation, don't feel like you have to throw all your eggs in one basket and buy these massive 1 or 2 terabyte solid state drives if you don't need them, especially if they're just going to be used for storage. Feel free to pick up a spinning drive, get a spinning drive as your second drive in your laptop. Use that for your storage. Keep your SSD at 500 gigs, 256, whatever you need for your applications to be installed and to do your work, and then store everything else on a secondary drive. That's totally fine. And a cost-effective move, I might add. Moving right along here. Next big consideration when it comes to hardware and building your machine, picking out all your components, is your video card. We get lots of calls about video cards, especially in relation to drivers. Big topic for us. So again, like the CPU, first big consideration. All right, do we want AMD or NVIDIA? SolidWorks releases certified drivers for both AMD and NVIDIA cards. However, once again, Hawkridge Systems does not have any workstations that we know about anyway, running AMD graphics cards. All of our in-office stations have NVIDIA Quadro cards. That brings us to our next topic, the gaming cards, and why you want to avoid them more specifically. AMD and NVIDIA both have a line of gaming cards and their workstation/professional cards, and they're different. The only reason we're talking about the gaming cards now is so that you understand we don't want these. Now, these are the AMD Radeons and the NVIDIA GeForce cards. If you have one of those, you will lose out on certain hardware acceleration features that come with the workstation and professional level cards. These gaming cards do allow SOLIDWORKS to function. Drivers can be an issue because there's no certified drivers for these gaming types of cards, but they do work, and we can help you with it. So if you have one of those cards, if you're stuck with it, give us a call. We'll help get you going as well as can be, minus those hardware acceleration features. That being said, the workstation line cards, these are your AMD Radeon Pros, Fire Pros, that's the old professional line. But more importantly, the NVIDIA Quadros. Again, we in-house here use NVIDIA Quadros. If you're dealing with troubleshooting driver issues, etc., that's where we're going to be best suited to help you. If you have an AMD card, we'll do our best, but the drivers for AMD cards have noticeable problems and issues. So that being said, okay, we want an NVIDIA Quadro video card generally, best we can do. Well, which card? There's so many video cards. We'll discuss that a little bit more on the next slide because I have a handy graph talking about sort of the levels of these cards. One thing I did want to talk about here briefly is recommendations for video cards in relation to other applications in the SOLIDWORKS suite, specifically your visualize and simulation. If you're trying to build a rendering machine, so a visualize machine, or if you're trying to build a machine strictly for simulations and processing those, first, I'd say definitely give us a call and talk to some of our professionals in those fields because they can give you recommendations. But those software suites can actually benefit from using the gaming line of cards. Excuse me. One of the big considerations here, though, is are these going to be dedicated machines? In which case, you could definitely consider getting one of those gaming cards for them. For example, if you have a visualize render machine, it's not going to run SOLIDWORKS, not doing anything else, just visualize. Yeah, you can definitely talk with one of our agents, and they might recommend for you to get NVIDIA GeForce card rather than Quadro. However, generally, if you're also going to be using SOLIDWORKS on the machine, because the Quadro cards can support visualize and simulation software, they just aren't quite as quick, then we'd say, well, GeForce, you lose out on a lot of features if you're running SolidWorks, so you're going to still want to stick with the Quadro card because you're doing SolidWorks and Sim, or SolidWorks and Visualize. I just kind of wanted to touch on that there for you. And here's what I was talking about as far as series considerations and which card you want to look at. This handy graph on the right, it even has the CAD programs, so SolidWorks is listed there around in the middle. And it kind of gives you an idea of the range we fall into. Now when you're looking at Quadro cards, the K series that you're seeing there kind of on the lower left, that's the oldest one that we really support. And I believe that SolidWorks still supports, actually. And there are still those cards floating around. There are certified drivers for them. But generally, since those are getting a little bit older, I would recommend aiming for the M series or the P series cards. P series, I think, is the newest one. Those are the Pascals. And you'll see they're kind of on the lower end of the SolidWorks bar. It's actually showing this M2000 card. Don't let this fool you. The M2000 is a very solid card for most users, engineers, etc. The P2000, obviously a little bit newer. It's going to be a little bit higher price point. But these kind of cards here, these are excellent options. Why you might want a better card? Okay, now you're starting to deal with even larger assemblies, or you're dealing with larger assemblies and simulation support, something like that. Sure. As always, you can talk to us about what kind of applications you're using, your concerns. We'll make recommendations based on that. One of the considerations here when you're looking at a video card is, for example, this P6000 we see up here in the corner. This is a $6,000 card. That's huge. That's bigger than most workstation budgets for a lot of companies. So you definitely want to pick the card that suits your application, so you're not paying thousands of dollars for something that is going to go largely unused. Just wanted to touch on that there for you guys. So again, M2000, P2000, right around there. There are M3000s and 4000s, so look into those. They're a very good starting point, or I should say mid-range point for most workstations. Drivers are a big consideration when we talk about video cards because they are the software that allows our video card to function correctly. Down here at the bottom, nice big letters, I have our link to the SolidWorks Certified Video Card Driver site. They allow you to determine your best video card driver either using your workstation model number. So you got a Dell 68 something, you can put that in there in their drop down fields and pick your version of SolidWorks and Windows, and they'll tell you which video card driver is the latest certified one for you. You can also, if you know your video card model number, for example the M2000, forego the workstation model stuff and just input the video card information, again Windows and SolidWorks, your version information, and they'll still give you the best recommended certified driver. NVIDIA releases for both GeForce and I even think the Quadros, I think they release like monthly driver updates, very, very frequent driver updates. SolidWorks just does not keep up with them in that, and to be honest, if you're constantly using the latest and greatest NVIDIA driver, you will guaranteed see quirks in SolidWorks. These drivers just aren't tested. SolidWorks goes through, they find the best ones that work for the majority of their cards, and that's what they recommend. So we do recommend sticking with the certified drivers, if at all possible. One of the reasons you might not be sticking with certified drivers, and this wouldn't be by your choice, is that Windows 10 has an automatic driver update feature built into Windows updates that got especially nasty after the Windows 10 Creators Update. If you're experiencing this, meaning if every time you open up your SOLIDWORKS RX, it's telling you have the wrong video card driver, your video card driver's too new, something like that, and you say, oh, well, let me get the right one. You download it and install it, and it looks good, and then the next time you restart, it's back. What's happening is every time you restart your computer, Windows Update is looking at that driver and going, oh, I have a newer one. and they're actually giving you the latest Windows certified NVIDIA Quadro and or GeForce driver, not the latest and greatest from NVIDIA. So all the more reason, if you're running into this issue, give us a call. We do have workarounds and fixes for it, and that will stop Windows from automatically updating your video card driver. That has been a big point of frustration for a number of customers. Some of you folks may have experienced that yourself. In relation to drivers again, let's say you have an NVIDIA Quadro FX 3700, something along those lines. Generally, this issue that we're talking about is more for older Quadro cards. You might be looking through the list and you'll see similar cards listed with certified drivers, but not exactly your card when you're looking at the SOLIDWORKS certified video card driver site. If you're having trouble with that, again, you can talk to us about it. We can give you the best recommended driver, but generally what you're going to be doing is find a video card that's close in model number, specs, etc., and see what driver that's using. That's probably going to be the correct driver for you. If you know, for example, mobile cards. So if you have a laptop workstation, you wouldn't have an M2000, you'd have an M2000M. Now that's not going to be listed on SOLIDWORKS supported video card site, but logic speaking, you would pick the M2000 as the appropriate driver, and that should work just fine. And generally it does. If you run into issues, again, speak with us. We'll be happy to help. Over here in the lower right, below our graph, I did put 4K with a question mark here in bright red letters. This was a consideration I just thought about recently, and that is, do you want a 4K monitor for SOLIDWORKS and your SOLIDWORKS Suite applications? With the 2018 version of the software, we're expecting SOLIDWORKS to fix all the fine-tuning with their 4K scaling, but right now, to be honest, it's not as pretty as it should be. If you're using SOLIDWORKS on a 4K monitor, or even your PDM client integrated with Windows Explorer on a 4K monitor, you're going to notice your icons, menus, just the overall feel seems like it's not quite together. Things are shifted. There might be overlapping icons, menus, fields, etc. This is, again, due to SOLIDWORKS not having the fine-tuning done in their 4K scaling. When will this be fixed? Again, we anticipate sometime in the 2018 year. I personally am not holding my breath too much. My recommendation is, if you're buying a mobile workstation, or even if you're buying a desktop workstation, don't invest too much into these 4K monitors, especially the laptop workstation. Just don't get the 4K screen. Just don't do it, because you know it's stuck on there. You can't just replace the monitor and be on your way like a desktop. Just grab someone else's monitor. Definitely something to consider there. So best you can, stick with the 1080 piece for now, or maybe keep your 4K off on the side for another application until SOLIDWORKS finishes up its 4K scaling. That would probably be indicated in the service pack too, so look for information on that in future service pack releases. Moving on here, talk a little bit about workstation recommendations. First things first, look at our guides. We release hardware guides every single year. They discuss all of the components similarly to how I am for the comprehensive guide anyway, but we also give general model recommendations. We pretty much stick to Dell and HP for our model recommendations because we've had the most luck with them as a vendor for us, but the similar hardware considerations can be applied to, you know, other vendors like Lenovo, etc. So once you have our hardware guides, and hopefully once your IT has our hardware guides too, send it to them. Now you got to say, okay, well, do I want a desktop or laptop? Well, the benefit of a laptop, obviously, is the mobile component. So do you need that mobile component? If you do, sure, consider a laptop, definitely. However, if you don't need that mobile component, a desktop is generally a better choice, let's say. Maybe that's a strong word, but a desktop is a good choice because it affords you upgradability. And that's something we'll touch on a little bit later, you know, when to upgrade, what do I want to do. But if you have a desktop and a component breaks, or if you decide, oh, geez, I've been using this and I have my NVIDIA Quadro card, but man, it's just not cutting it, you can pop out the video card, pop in a new one. It's, you know, it only costs you what the video card costs. On a laptop, that means a whole new laptop if you wanted to go that route. So upgradability, big consideration for desktops. Next thing you say is, okay, so I want a desktop or laptop. I know that, but where do I get it? Well, like I mentioned earlier, we offer recommendations for specific Dell and HP models that will suit your needs. You can look at other big name vendors, or you can start getting into those custom PC builders like Main Gear, CyberPower PC. If you're going to be looking toward that route, definitely consult with us and speak with us on what you're looking at and why. If you're looking at Main Gear because you want overclocked video cards, because you're also going to be, in addition to SolidWorks modeling, you're going to be doing rendering your sim. Sure, that's reasonable. Or if you're a big enthusiast, crazy IT person like me, and you want to build the machine, sure, that's fine too. However, with those two applications, the custom and building it yourself, we would recommend that you talk with us about it. Guys like me, I might be able to point out hardware incompatibilities, like, oh, hey, this RAM doesn't work that well with this motherboard, things like that. So, as always, feel free to talk to us. And here are some recommendations for a Dell laptop and desktop. I believe the only difference between the 5000 and the 7000 is the monitor size. I think it's a 15 versus 17. I may be mistaken there, though. But yeah, Dell desktop and laptop listed here. These are the kind of things you'll find in our hardware guides. Next topic we want to touch on, this is one of those hardware-software relations, is VMs. For those of you who don't know, VM stands for virtual machine. It's a software that you run on a server, and hopefully you're running one of our supported VM softwares, but that allows you to create instances of an operating system, in our case, which should be Windows, and it allows clients to connect to those instances and essentially run a computer and multiple instances of it off of this VM server. So this should not really be a consideration if you're a standalone user, and that's one of the reasons I put this in here. If you're using standalone licenses, you should not be dealing with VMs as far as trying to get your standalone license to activate on a VM server and utilizing it that way. That actually violates SolidWorks EULA, so don't do that. Not a good idea. However, when you're looking at say your Solid Network License Manager for network licenses, or your PDM server, and there may be a few other cases, but that's when you'd want to consider a VM. For example, Solid Network License Manager server. It's such a simple application, you can spin up a very low-end VM and everything will function correctly. That being said, we're talking a lot about VMs. There is a list of supported VMs on SolidWorks support page. It's the link is there at the bottom of this page. There are a number of unsupported VMs. If you are using one of those and you are encountering problems specifically with that, we're not really going to be able to help you. We don't have those in-house. We don't have a means to use or test them. We can only really effectively help you on the supported VMs, and even then, there are some limitations we have here. Linux VM. For those of you who don't know, you can have a Linux-based server that emulates a Windows virtual environment. If you're trying to do this for, say, your network license manager, again, that piece of software, don't do it, because SolidWorks tailors all of their software to work with Windows, and they actually hard code in checks to see if you're running a Linux backend. If you are, you won't be able to activate your software. So before you spend money on a Linux server, don't do that. Get a Windows-based server, and everything will be okay. One last big consideration for VMs, and I mentioned it earlier, is PDM. Hosting your PDM server on a virtual machine is totally fine. It's acceptable as long as you're using one of our supported VMs. Please look at that list first. Yeah, the system requirements for a PDM server are generally on the lower end. I mean, you can get away with 8 gigs of RAM, not that much processor speed, but you do need a large amount of hard drive space. If you're going to be building your PDM server on a virtual machine, give us a call. We'll talk about general recommendations, especially speak with someone like me, and I can kind of help you through what some of the quirks might be. Again, this link at the bottom is for our the SolidWorks officially supported VMs. I did want to talk about Macs and Mac VM kind of a little bit separately, subsection of VM, if you will. First of all, if you're trying to use Macs for SolidWorks, don't do that. Dassault didn't design SolidWorks to be run on OS X. It's Generally, not a good idea. You wouldn't want your IT to run out and buy a whole bunch of MacBook Pros and then, say, hey, these are going to be our SolidWorks workstations. Bad move. If you have a bunch of Macs lying around and that's all you have that could potentially act as your SolidWorks workstation, etc., then yeah, there are solutions for you. The officially supported VM software for OS X and Macs in general is Parallels, actually. Um, why they went this route, not too sure. I believe it's because Mac pushed it, but Parallels works. It by default does not allow you to use the hardware acceleration from the video card on your Mac side, because if you look at this window or this picture on the right here, you'll notice there's your OS X operating system, and then there's Windows open like a window, coincidentally, in the background there. That's Windows being emulated in OS X. So generally the software performs well enough, Parallels that is, but to be honest, I actually do prefer Boot Camp. Now, Boot Camp is not a supported virtual machine. So if you're running Boot Camp on your Mac and you're trying to call in because, oh, this particular hardware component won't seem to start right, won't work, that's more of a Boot Camp issue, and that might be something to bring to the attention of your IT people. They might be a little bit more geared to help you with that. I did mention a couple times, if you're using Parallels, you might lose out on hardware acceleration. Some MacBooks, Mac desktops, they do have Quadro cards in them, or Radeon Pros even. So you actually could, in theory, run SolidWorks with these video cards, and you could run it with all the hardware acceleration, except Parallels by default locks you out of those options in SolidWorks. This link here at the bottom is an article I wrote, and it links to a page where they found all the registry keys that you need to hack for each year version of SolidWorks to enable the hardware acceleration options. So this basically allows you to turn on RealView. It allows you to uncheck, use, I think it was software OpenGL mode. So you can actually enable hardware acceleration. That is again, if the video card you have actually supports those features. If it does not, then you'll be able to click your check boxes, click your options. You won't see anything visually different. It'll just be available. On to our tips section. I said this a couple times, but once more for good measure, talk to us about your specs, especially before buying. After buying, it's a lot more of a headache, right? Make sure your IT has our guides. Apologies, the link got cut off here, but this is the same link from earlier on on the Workstation Recommendations page. That's what it was. This is the same link, just to our hardware guides. There are two, again, comprehensive and recommended. Comprehensive would be much more suited for your IT, a lot more information in there for them. But get them both, either way. What to buy? Again, we kind of touched on this a little bit, but really getting a tailored Dell machine or HP machine is going to be just fine for you. Just make sure you have the right video card, right amounts of RAM, right hard drives. One little caveat I noticed about the HP website recently is you'll be looking at models, even some of the ones we recommend in our guide, because this guide was written before they made this change. But there's only a few models now on the HP site, specifically when looking at laptops too, that say customize and buy. A lot of them just say buy, which means you get whatever standard specs are listed right there, below the model name. That's not really what we want. You want to be looking for those customize and buy options if you can see them on the HP page. Anyway, that aside, more importantly, we've kind of discussed what to buy and where a little bit already, but upgrades. When and what? Okay, so generally we're going to recommend, you don't have to buy a high-end system. You don't need that P6000 video card. You don't need the crazy 16-core Xeon. But, get yourself a 7700K and an M2000 video card, and 2 or 3 years down the line, you'll be able to upgrade your machine to another mid-range machine, generally costing $1,500, $2,000, maybe $2,500 if you throw in a few bells and whistles. This generally fits the budget of most companies. But if, for whatever reason, your company says, well, we only buy new workstations every 4 or 5 years, If that's the case, with the rate at which technology is progressing, I would highly recommend aiming for some higher end hardware. So, get that bigger video card, get a little bit more RAM, and get that faster processor. Because by the time you're hitting that 4 year mark, I mean, we're talking what, SOLIDWORKS 2021, this machine's going to be dragging for you. So, again, 2 to 3 year, buying mid range, that's a good idea for upgrades. I did want to touch a little bit here on some troubleshooting techniques and ideas. Specifically, Windows has a built-in utility that will tell you if it thinks your hardware is functioning correctly, and this can give you information about driver problems too. And that's your Windows Device Manager. You can get to this thing just by clicking on your Start menu icon, start typing Device Manager, and it should show up in your search list in the Start menu. Open that up, and it looks like this window here on the right, minus the properties there. What this is the list of all of the hardware components that Windows detects in your computer. And if there's any problems with any of these components, that if you look at the resource monitor warning there, the yellow exclamation mark, there'll be a circle version of one of those next to the specific component. Kind of like how this slim type DVD drive is illustrated in this picture here. It has a question mark because Windows doesn't really know what it is. And it thinks it's working properly, but it doesn't have any proprietary drivers for it. That's why it has that question mark there. If there was a driver problem, there would be a yellow exclamation mark, and if you look under where it says device status there on the right, it would say, oh, the driver's wrong, or this device cannot start, or start code error, something. This is an indication to you that there's something wrong with this device. And first, if it's not a display adapter or video card, I would recommend show this to your IT first. They might be better suited to help you with this issue. If your video card is the issue, now look over here, it says display adapters. That's your video cards. I know, not the most commonly used term, but if you're seeing a drop down here and your video card has a yellow exclamation mark and you look over here into the status and it says there's a driver problem, that would be a good time to call us. If it's specifically not that the hardware is not functioning, not starting, but that it's a driver issue, that's where we can come in handy for you if you're unable to locate the driver on your own, that is, given the web page. Last thing to touch on here, resource monitor warning. Most of you probably seen some iteration of this when you first started SOLIDWORKS after the first install. It's very common to see it'll come up and say, oh, hey, your SOLIDWORKS RX application should be opened. Look at the diagnostics tab. Make sure your system is up to spec. That's common. However, if you're turning on SOLIDWORKS or running SOLIDWORKS and you start seeing this resource monitor warning show up often, it could be related to a bug, or you could be running low on RAM, or your processor could be topping out. Best way to check is when you see this warning, open up your Windows Task Manager. Again, you can do this from the Start menu, and look at your Performance tab, and look at your RAM consumption, or memory consumption, if you will, and your CPU. If either of these are starting to top out, then this warning is coming up for a reason. Most commonly, when this warning is valid, we see it because the user is just running out of RAM. Once you hit the 70 to 80% mark, this warning shows up. And once you hit the, I think it's 85 to like 92% mark, the warning becomes critical and SOLIDWORKS has a high chance of crashing on its own. So again, if you're seeing this warning and you're not sure how to check on those resources, talk to your IT. If they can confirm that, well, geez, your RAM usage is at 25% and your processor usage is at 5% while this warning is popping up, then definitely give us a call or shoot us an email, and we'll be happy to offer some of the fixes we have for when this error is bogus, or excuse me, when the warning is bogus. I guess one thing I could touch on here quickly is the SOLIDWORKS RX application. Now, this application can be real handy. Again, if you open that up and go over to the Diagnostics tab, there's information on there about your system, and more specifically about the video card driver that the RX application is detecting you're using. This is a real easy way, using this RX application makes it very easy to determine if you have the correct video card driver, and it's so helpful as it will even recommend you a driver if it can detect your video card and offer you a download button. So you'd be able to download the latest certified driver for you right there. Really, like I said, really good tool for determining if you have the right video card driver software installed. Check it out. I've mentioned a number of times, you guys want to contact us for this, that. Here is how you would do so. Our chat system is built into our Hawkridge customer portal. The Hawkridge customer portal is free. Go ahead and sign up for one. We do link it to your company account, so that's how we keep track of everything. But in it, you have the ability to track your tickets with us and chat with us, which is a nice handy tool for some of the easier issues. And now I want to open this up for questions. I did have a few questions come in regarding multiple processors and Visualize. We did touch on that a little bit. Visualize does utilize multiple cores threads. So, like I said, generally, those i7 7700, 8700Ks, they'll probably do you just fine. But, you know, if you're going to be building a tailored rendering machine, I would get on the phone with one of our Visualize experts or simulation experts if that's your application, and have them help you decide what's best for you, what falls within your budget, etc. You know, these are kind of tailored machines. You want a kind of tailored recommendation for you. I am going to be sending out this PowerPoint for you, and there should be a recording going up on the Hawkridge video page. I think it eventually makes it to our YouTube. Apologies, this is my first Webinar Wednesday live, hooray, but I hope you guys have enjoyed it so far. If there's any additional questions, feel free to contact us. We're always happy to help. Thank you. Oh, one last thing here. Upcoming Webinar Wednesdays, we have a few more coming up here, 22nd, 29th. And already. Well, thank you guys so much for attending. You have a great day.